So today, let's go ahead and take a look at the Pythagorean theorem converse. Now, the Pythagorean theorem, as we learned a few days ago, states that if a triangle is a right triangle, then a squared plus b squared equals c squared. In other words, if a right angle has a 90-degree angle, it makes it a right triangle, then we can use a squared plus b squared equals c squared to find any missing values. Now this is very helpful when we have a triangle and we are missing one of our three values. If we're missing one of the legs or if we're missing the hypotenuse, we can use Pythagorean theorem to solve for the missing value. But sometimes we know all three side lengths and we don't know if it's a right triangle. So we can use the converse of Pythagorean theorem. Now first let's talk about what the converse of the Pythagorean theorem is. A converse statement. So the converse of a statement is made by switching the if and then statements. So looking at Pythagorean theorem, our if statement is a triangle is a right triangle. Our then statement is a squared plus b squared equals c squared. So for the converse of Pythagorean theorem, I'm going to switch those two. So the converse of Pythagorean theorem is if a squared plus b squared equals c squared, then the triangle is a right triangle. So we're going to go ahead and try and test this out. So let's go ahead and draw a triangle. Now we don't know if it's a right triangle yet or not, but I am going to plug some values in. So I'm going to plug in one side is 5, another side is 12, and another side is 13. Now, looking at our three values, since we don't know if this is a right triangle or not, we need to figure out which one would be the hypotenuse. And remember, the longest side is the hypotenuse, so I'm going to say that 13, I'm going to name that C. Then 12 would be one of the legs, so I can say that's B, and 5 would be the other leg, so that's going to be A. So let's go ahead and plug in our values to the theorem. So A squared becomes 5 squared, B squared becomes 12 squared, and C squared becomes 13 squared. Now I know that 5 squared is 25, and 12 squared is 144. And 13 squared is 169. Now 25 plus 144 is 169. And I notice it's the same thing as c squared, 169. Both sides are equal to each other. So yes, this is a right triangle. So let's go ahead, let's make that our example number 1. Let's go ahead and do an example number 2. In example number 2, I'm going to draw another triangle. Again, I don't know if it's a right triangle, but I am going to plug in some values. I'm going to go ahead and name this side 8. This side will be 9, and this side will be 10. Now looking at our three values, I notice that the 10 is the largest number, so that would have to be our C. So if this is a right triangle, that would be the hypotenuse. And then I'm going to go ahead and name this side A and this side B because those are the other two legs. So let's go ahead and plug in our values. A squared plus B squared equals C squared. So this time A is 8 squared, B is 9 squared, and C becomes 10 squared. So 8 times 8 is 64 plus 81. 9 times 9 is 81. and 10 times 10 is 100. Now I can already see that 64 plus 81 is a lot larger than 100, and I do find out that they are 145 is not the same thing as 100, so this is not equal. So no, this is not a right triangle. Not. So just to review, if a triangle is a right triangle, then a squared plus b squared equals c squared. But we want to use the converse. If a squared plus b squared equals c squared, then we can say the triangle is a right triangle.